What's up? I'm Vin, and today I want to go through some GED math. Now, this practice test you could download in the description, and the calculator I'm going to use is just a basic 4-function calculator. So first up here, we have Raymond is ordering these expressions and wants to know of these expressions, which one has the greatest value. So what I would do right away is cross off the ones that are obviously not the greatest. So if I'm comparing square root 25 to square root 8, I would cross this one off because square root 25 is obviously greater. And this is actually equal to 5 because 5 times 5 is 25. That's just the definition of square root. So if I take the cube root of 5, now that may be obvious that it's smaller than 5, but there's other ways that we could reason out that the answer choice is going to be A. For one, the cube root of 5 is smaller than the cube root of 10, but how do we know that square root 25 is bigger than cube root 10? So this could come from mental math, but what we could do is we could express 5 as a cube root. And just know, if we were to do 5 times 5 times 5, 25 times 5 is 125, which tells us the cube root of 125 is equal to 5. So because choice A could also be expressed cube root of 125, that's obviously bigger than cube root 10. So definitely choice A. So question 2, we have 5 to the third power, and this exponent up here, 3, tells us to multiply the base 5 by itself 3 times. And then 5 times 5 is 25, and then times 5 again is 125. So here's our solution to 2. Question 3, we want to know how many different ways can 6 different positions, that's the $1 million phrase right here, different positions, be filled by 12 applicants. So for questions like this, what I like to do is just list out the positions here. So we have 1, 2, 3, 4, 5, 6 positions, and there are 12 applicants. So you have to think, how many options are there for the first position? Well, there's going to be 12 options for the 12 applicants. But then once somebody has been selected for the first position, now there are 11 people left. And then for the third position, there'll be 10 people to choose from, then 9, then 8, then 7. And we're going to multiply these 3 together. But this is just all calculator work here. We're not going to do the long multiplication. We'll use a basic calculator for this. And if we work this out, this is going to be equal to 665,280. So there's quite a few possibilities here. We'll just record this in the answer spot. Question 4, we're solving this quadratic using the quadratic formula. Now, if I could do this any way I wanted, I would use factoring, but we're being told to use quadratic formula. And just know that the general form of a quadratic equation, we have ax squared plus bx plus c. So what I like to do for these is identify the a term, b term, and c term. A is the number in front of x squared, and in this case, the invisible number written here is 1. And then we have b is equal to negative 5. A common mistake is that people just say 5, but notice it's plus bx. So the fact that there's a minus 5 tells us the minus has to be included when we define our b term. And then the constant at the end is minus 14. So now what we're going to do is we're going to plug into this formula. We have x equals negative b would give us negative 5. And then we have plus or minus the square root of, we have b squared minus 4 times a times c. And c is equal to negative 14. And we're dividing all of this by 2 times a. So then what we're going to do from here is just simplify. We have x equals minus 5 is positive 5. Plus or minus, and we could use a calculator for this, but we'll just work this out. So negative 5 squared is 25. A negative times a negative goes positive. And then if we do 4 times 14, that's going to give us 56. And we're dividing all of this by 2, which is just simplifying 2 times 1. So now we'll carry this over here. We're going to have x equals 5 plus or minus the square root of, and if we do 25 plus 56, that gives us 81. And notice this is a perfect square, so that means this is going to work out to a nice answer. And we're dividing by 2. So this is now x equals 5 plus or minus the square root of 81 is 9 divided by 2. And now this part sometimes throws students off, but what you want to do is you're going to write 2 separate equations, or 2 separate possible x values. We have x equals 5 plus 9 divided by 2. And then we have x equals 5 minus 9 divided by 2. If we work this one out, this is 14 divided by 2, which is 7. And the second one gives us 5 minus 9, which is negative 4, and divided by 2 is negative 2. So here are the 2 possible solutions for x using the quadratic formula. Question 5, we're plotting these 2 points, and then we want to find the slope of the line that connects them. So what we're going to do is the point -5, 4, we're going first to the left 5. That first number tells us how far left or right to go. So we go to the left 5 units over here, and then the second number tells us how far up or down to go. So since it's +4, we're going to go up 1, 2, 3, 4 like this. So that's the first point. And now the second point, we're going to the right 5, down 4. So we're going to the right 1, 2, 3, 4, 5, and down 1, 2, 3, 4. And now the next thing we want to do is find the slope of the line that connects them. And to do that, we're going to use this formula. The slope is y2 minus y1 over x2 minus x1. It really helps when you're new to this to label these. So this first point here I would call x1, y1, and the second point I would call x2, y2, because then now when we want to find the slope, we have m equals y2 is -4 minus y1 is 4 over x2 is 5 minus x1 is -5. And now we simplify this. We have m equals -4 minus 4 is -8 over 5 minus -5 changes to 5 plus 5, and then 5 plus 5 is 10. And then it's a good idea to simplify your fractions. If we divide the top and bottom by 2, this is going to simplify then to -4/5. Now, one thing I do to kind of check my answer here is I notice the line connecting them is a line that's decreasing, because notice the line is dropping. And anytime you have a line that's decreasing, your slope is negative. If the line were to go up, the slope would be positive. So -4/5 is a good answer. So question 6, we're going to plot these points, and then we're going to connect them to form a straight line. So we have first the point 0, 3. So we're going to the right or left 0. So we're not moving from the origin or the center 0, 0. And then we're going up 3. So we're going up here. So that's the first point here. And then 1, 5, we're going to the right 1, and we're going up 5 units like this. And then the next point would be over 2 and up 7. Now, we ran out of real estate a bit, but that's fine. We'll just connect these now with a straight line. So here's the line that connects these 3 points. So first we'll plot -1, 1. So we go to the left 1, up 1, and notice this point lands on the line. So this one is good. And then if we go to -1, -1, the problem with this is we're going to the left 1, down 1, and notice that we're off of this line here. If I make this a little bit darker, so this line here in red, that this point falls off the line. So that's not one of the solutions. Now 2, -4 is also something that's not on the line. We go to the right 2, down 4, and notice here this point falls off the line. So I'll put the ones that fall off the line in red, and we'll cross them off. Now the point 2, 0, oh, I'm sorry, -2, 0, we're going to the left 2, and we're going up 0. So notice that lands on the line here. So this is definitely one of the points. And then the last one to look at, 4, -1, we go to the right 4, down 1, and notice that point is off the line. So we cross it out. So A and D are the 2 points that land on the line. So question 8, we're going to find the slope between these 2 points. So remember that formula from before. We have y2 minus y1 over x2 minus x1. Now, I highly recommend when you do questions like this that you take that extra second to label, because this just helps you stay more accurate. So the first point, call x1, y1. The second point is x2, y2. So now the slope, we're going to do y2 minus y1. So y2 is 5 minus y1 is equal to 1. And we're dividing by x2 minus x1. And that's going to give us 5 minus 1, which is 4, over 3 minus 2, which is 1. And 4 divided by 1 is 4. So that is the slope between these 2 points. Question 9 has mean, median, and mode. And we want to match the measures on the left with the values on the right. So the first thing you should do when you have a data set is put it in order from least to greatest, which they already did for us, so that was polite. So now the median is the middle value, but notice that we have 6 values here. So when you want to find the median and there's an even amount of values, what you do is you take the set on the left and the set on the right, and the median is the number that would fall between 32 and 46. So then what you could do is, there's a few ways you could find this. You could do 32 plus 46 divided by 2, or if your mental math is sharp, what you could do is you could look at this and say 32 and 46, if you subtract those, are, let's make that a little neater, are 14 units away. So the halfway point, I would take 14 and divide by 2, and that's 7. So then I know to do, on the next thought, to take the first number 32 and add 7 to it, and that would bring us to 39. Otherwise, we just take the average of those two, and then if we do 32 plus 46, that's 78 divided by 2 is 39. So the median should be 39, and check out here that this matches right up with A. Now mode is the one that appears the most. So the one that shows up the most is 46. So that's our mode, and that's going to match up here with D. And now next is the mean. This one's probably the most tedious to calculate. To find the mean, you add up all the digits, or you add up all the values and divide by the number of values. So what we would do is we would take 15 plus 24 plus 32 plus 46, and then we're doing another plus 46 and then plus 58. And notice that we added together 1, 2, 3, 4, 5, 6 values, and this is what we're doing. So we'll simplify the numerator first. If we add these 6 values together in a calculator, we're going to get 221, and now we divide by 6. So just do 221 divided by 6, and this equals 36.83, and that's going to match up with choice B. So this one matches here. Now, just by process of elimination, the range is going to be 43. But what we do to find the range is that's going to be the distance from the smallest value to the greatest value. So if we just did 58 minus 15, notice here that this works out to 43. So that's where the range is coming from. For question 10, we want to earn a 90 in a class. And on the first 3 tests, we got 90, then we have an 89, and we've got 95. And on the 4th test, that's what we're looking for. What percent do we need on the 4th test to earn a 90%? So the way we calculate percents, or our average, is we look at all of our test scores. So the 4th test, we don't know what that score is, so we're going to call it X. But what we do know is that we want to get a 90 average here. So that means when we add up the 4 test scores and divide by 4, that has to equal 90. And in a moment, we're going to cross multiply. But what I would recommend that you do first is simplify. Do 90 plus 89 plus 95. So we could simplify this a little bit. That's going to give us 274 plus X, and we're writing this over 4 equals 90. And now to solve for X, I'm going to call this 90 over 1, and we're going to cross multiply like this. So if I do 1 times 274 plus X, well, just know 1 times anything just gives you whatever you're multiplying it by. So that's just going to give us 274 plus X equals, and now we do 90 times 4, that's 360. So then to solve for X, the 4th test score, we subtract 274 on both sides. And for this one, we could practice doing long subtraction. The 4th test score here, we're going to borrow this and make it a 5. And now we have 10 minus 4 is 6. And then here, what we're going to do is make this a 2, turn this into a 1, and 15 minus 7 is 8. So that tells us that the 4th test score has to be an 86. Question 11, we're writing 114,000 in scientific notation. Now, the direct way to do this is you take the number, and notice here, 114,000, we're going to write it like this, and I'm going to put a decimal and a 0. Now, all the answer choices start with 1.14, and the reason being is when you're writing a number in scientific notation, the decimal is going to land between the first 2 numbers, where the first number is non-zero, and the second number could be 0, but the first number has to be non-zero, and that's why all the answers look the same. But then what we have to do is we're multiplying by 10 to some power. So the mystery power comes from counting how many times you have to move the decimal to get from where it is now to between the 2 numbers here, the first number and the second number. So we're going to move this decimal 1, 2, 3, 4, 5 spaces. So that's why this is going to be 10 to the 5th power. Now, one thing that jumps out of people is, how do you know it's not 10 to the minus 5? And the reason for that is that if I look at choice A, which is distracting, this is a common wrong answer, is that if I want to actually expand this, what I would do is I would write 1.14 like this, but I would actually put zeros to the left. So this is not a proper way to write a number, but the reason I do that is if I'm doing times 10 to the minus 5, that takes the decimal, if I'm going from scientific back to standard, and it tells you to move the decimal to the left instead of the right. So then here I would take this and I would go 1, 2, 3, 4, 5, and I would place the decimal here. So this is actually equal to 0. We'd have 4 zeros. So we'd have 4 zeros after the decimal. Then we would have 114. So That's why it's not choice A. Anytime you have a negative power of 10, it's telling you to move the decimal to the left, but the positive power of 10 tells us to take this decimal and then move it to the right. That if we wanted to go back, what we could do is we write our number with a bunch of zeros at the end, and then when we multiply by 10 to the 5, it moves the decimal to the right. 1, 2, and let's fix that. 1, 2, 3, 4, 5 spaces. And notice that gives us 114,000 if we were to look at the whole number. Question 12, we want the sum of 3 consecutive odd numbers to be 135. Now, use processes of elimination here. The 3 numbers have to be odd and they have to be consecutive. Now, odd numbers are numbers that end in 1, 3, 5, 7, or 9. And odd numbers are not divisible by 2. But notice, choice A, these are all odd numbers and they are consecutive. Consecutive means the ones that happen one after the other. So these are consecutive odd. Choice B is also consecutive odd numbers. Choice C, notice that 44 is even, so we could cross out choice C. And in choice D, we have even numbers here, so we could cross this out as well. So in choice E, we have consecutive odd numbers. So now we've narrowed it down to 3 choices. But if we want to find this the technical way, because what I could do here is, if I just want to get this right, honestly, you could just sit there and you could add choice A, you could add the stuff from choice B, and you could add the stuff from choice C. So this is probably like, the safest route to go here. And if you add this up, 5 plus 3 is 8, plus 1 is 9. So notice the last number should be a 5. It should be 135. So I'm already crossing off A because I have to end with a 5. And notice here, 7 plus 5 is 12, plus 3 is 15. I would probably, if I want to do this more carefully, do 7 plus 3 is 10, and then plus 5 is 15. And now when we carry the 1, we have 4 plus 4 plus 4 is 12, plus 1 is 13. So right away, it's looking like this one. And then choice E would send us too far. So that's just by process of elimination and then just adding up the actual ones here. So that'll get us to choice B. If you want to do this algebraically, so a second way, which is more painful, but it will get you there directly, is you could say the first number. So the first number is x. But one thing to be careful with, if I look at consecutive odd numbers, notice I conveniently have 1, 3, 5, 7, 9, the first set of positive odd numbers. And to get from one odd number to the next, we're doing plus 2. So every time I want to find the next odd number, I add 2. A common mistake is that people would just say, oh, consecutive, so plus 1, but it's consecutive odd. And now the second number would be x plus 2, because once again, the pattern is odd numbers occur every 2 whole numbers. And then the third number, if I did plus 2, x plus 2 would give us x plus 4. So if you add these 3 up, x plus 2 plus x plus 4, this would be equal to, we would have 135. And now we could just do the algebra. X plus x is 3x. And then we have 2 plus 4 is 6 equals 135. And now what we could do is we could subtract 6. That's going to give us 3x equals 6 minus 6 cancels, and 135 minus 6 is 129. And then notice what we have here. If we divide by 3, we could just do the long division. X equals 12 divided by 3 is 4, and 9 divided by 3 is 3. So x equals 43, that's the first number. And then after 43, the next odd number, 43 plus 2 is 45. And then x plus 4, the next one here would be 47. So 43, 45, 47 is definitely the answer. So this is like the heartbeat question from before, but now we're talking about fingernails. And we're taking this number here in scientific notation, and we want to express it in standard notation. So what I like to do for these questions, yet again, is if I'm doing this, what I like to do is I write the number down, 2.8, and I'm going to put zeros in front of the number. Even though that looks ridiculous, I'm writing this out because if I'm doing 2.8 times 10 to the negative 3, this exponent is telling me, since it's negative 3, that we're moving not to the right 3, we're going to go to the left 3. We're going to go 1, 2, 3 like this. And that's where the decimal is going to land. So this value up here is going to be equal to 0. And now we're going to have, notice the decimals here, we have 2 zeros, and then we have our 28. So that's going to correspond to choice B. So for the next few questions, we're evaluating these exponential expressions. Now, the first one, we have a negative exponent. And just know, anytime you have a negative exponent, I'll write this rule. A to the negative b is the same thing as 1 over a to the positive b like this. So question 14, I could rewrite this as 1 over 3 to the second power, and that's 1 over 3 times 3, which is 1/9. So this is our solution to 14. Now for 15, just know any positive number to the 0 power is equal to 1. So this one here, we could just say is equal to 1. And there's our solution to 15. So question 16, we have 18 to the first power. That's just going to be equal to 18. All right, just know that if we had something, let's just make that a little neater. If we had 18 to the second, we would have to do 18 times 18. But 18 to the first, you just rewrite the number, it's 18. Now, the next question here, 10 to the fifth. When I'm doing something like this, I think about patterns. You know, like 10 to the first is equal to 10. 10 to the second is 10 times 10 is 100. So when I have 10 to a power, and that's it, I write a 1. So this one here is equal to 1. And let's give a little space here. So this is equal to 1. And then I'm going to write 5 zeros. So I have 1, 2, 3, 4, 5. Because notice 10 to the first was just 10. That's a 1 with 1 0. 10 to the second is 100. That's a 1 with 2 trailing zeros. So 10 to the fifth is a 1 with 5 trailing zeros. So that's our solution to 17. Now, for the next one here, we have 9 to the negative 2. That's kind of like the first question here in this set, like question 14. So this one here is going to be equal to 1 over 9 squared. And 1 over 9 times 9 is 1 over 81. So that's our solution to 18. Now 19, when we look at this question, we have 15 to the third power. Now this I'll just write over here. That's 15 times 15 times 15. So 15 times 15 is 225. And we still have to multiply by 15 once more. So this part we could just use a calculator. And this will work out to 3,375. So that's our solution to 19. Question 20, we're solving for x. And this is something that you want to be skilled with, solving a linear equation for x. So for this, what you have to know is you have to know the distributive property, that anytime you have a number times the sum of two numbers in parentheses, this is equal to, in this case, a times b plus a times c. So what you essentially do is you do the number on the outside times the first term plus the number on the outside times the second term. And if we use that idea for this, we have negative 2 times x, that's negative 2x. And then we have negative 2 times 4 is minus 8. And equals, we'll leave the right side alone for now. So now the goal is to solve for x, but notice we have x's on both sides of the equal sign. So if I have a minus x and a positive x on one side or the other, I like to move the minus to the other one. So the opposite of minus 2x is plus 2x. So I'm going to do plus 2x on the left, and I'm going to do plus 2x on the right. Just know the golden rule of algebra is that whatever you do to one side, you have to do to the other. I can't just add 2x to the left and not do anything to the right. If I add 2x to the left, I have to repeat that on the right side. So now on the left side, negative 2x plus 2x cancels, and we're left with just minus 8 equals, and now these are like terms. They're both x terms. So 5x plus 2x, I'm just going to add the numbers in front of the x. 5 plus 2 is 7. So you have 7x plus 6. And now to solve for x, notice this plus 6, to get rid of it, we're going to do the opposite, which is minus 6. The general idea when you're solving for x, when it's a linear equation, when it's x to the first power all around, is you want to just keep doing the opposite operations to get x by itself. So now we have negative 8 minus 6, that's negative 14, equals, and we have 7 times x. And now from this step here, to solve for x, we're just going to divide both sides by 7. And now x equals, we have negative 14 divided by 7, and that's going to be negative 2. And this is going to be choice A. Now, because it's multiple choice, we don't actually have to know how to solve an equation. We could get away with this by just plugging in answer choices. So let's say you just said, all right, I think x is equal to negative 2. Let me try choice A. Then you'd have negative 2 times x is negative 2 plus 4, and this equals 5 times x is negative 2. So you could just plug in, and then plus 6. And if we work this out, this is negative 2 times negative 2 plus 4 is positive 2. And now 5 times negative 2 is negative 10 plus 6. Just know when you're simplifying something like this, you should know order of operations, and this is a helpful mnemonic for it. We say, please excuse my dear Aunt Sally. And just know that when you have parentheses exponents, you do those first, then multiplication, division comes next, addition, subtraction. So that's how I know the order in which to do things here. So now we've got negative 2 times 2 is negative 4 equals, and negative 10 plus 6 is also negative 4. So choice A checks out. So question 21, we're connecting the verbal representation to the actual equation. So which of these represents this equation? So 4 more than x. So this one would read 4 more than x is x plus 4. So far so good. Equals, and 6 less, that means minus 6 at some point, the quotient of 5 and x. Well, this one here, the order in which it's written sounds like the quotient of 5 and x sounds like 5 over x. So that's why this one is just a little bit off. So the wording here is not that nice. But if we look at the next one here, we have the sum of 4 and x. And with addition, the order doesn't matter. So I could say 4 plus x, or I could say x plus 4 equals, and this is the same as, so is the same as is telling us equals 6 less than. So 6 less than the quotient of x and 5. Well, 6 less than something means you're subtracting 6 at the end. Then what we have is the quotient of x and 5 is x over 5, because notice the x was written first. So this one here is looking like choice B. Now, if we look at the last answer choice, 4 increased by x. So I'll write that here. We have 4 increased by x, that's x plus 4, equals the difference of, we have x and 6 divided by 5. So that's what choice C would say, which doesn't match what's written here. So B is looking good. Question 22, we're told the sum of 3 consecutive even numbers is 138, but we want to find what's the greatest number. So consecutive even numbers, if you think about this, if we look at some consecutive even numbers like 2, 4, 6, 8, 10, and so on, notice that the numbers increase by 2 each time. So we could define stuff algebraically. The first number we could call x. The second number would be x plus 2, because consecutive even numbers, the pattern is to get from one to the next, we just add 2. But then the third one would be x plus 2 is x plus 4. So this is the same idea as the question from before, that the sum of these, so we add those together, so we have x plus 2 plus x plus 4 is 138. And now here, if we do x plus x, that's 3x, and then 2 plus 4 is 6, equals 138. Now just do minus 6 on both sides, and you've got 3x equals 132. And then from here, just divide everything by 3, and that's going to tell you that x equals 13 divided by 3 is 4, with a remainder of 1, and then 3 goes into 12 4 times. Now this answer choice here is very dangerous, okay? This is a serious bear trap. If you choose 44, it's very sad because it shows that you know what's going on, but you just weren't careful. X represents the first number. So x is equal to 44, which means the second number is 44 plus 2, which is 46. And then the third number, 44 plus 4 is 48. We want to know what's the greatest number. And out of the 3 consecutive integers here, the 3 consecutive even integers, notice that 48 is the biggest number. So we would go choice C here. Question 23, we have Jonathan drives at an average speed of 62 miles per hour for 4.5 hours. How many miles does Jonathan travel? So for this one here, we have to be skilled with certain formulas and certain units of measurement. So here, just know that the velocity, or in this case, average speed, I'll just call S, is equal to distance over time. And if I call S, let's say S over 1, we could cross multiply, and that tells us D times 1, or D, is equal to S times T. Now, this is a formula that you could just know that this is distance traveled, and S represents average speed, and then T represents time traveled. Okay, so this, you might have a basic intuition of this, that if I said, let's say, something like Hank drives 60 miles per hour for 2 hours. This is sort of intuitive, where you would say, all right, well, if Hank drives 60 miles per hour for 2 hours, then he's going 60 miles for the first hour plus 60 miles for the second hour. So that's 120 miles. Okay, or you could just do 60 miles per hour times 2 hours, giving you 120 miles like this. So if we use this formula, now we just have to define stuff. The average speed is 62 miles per hour. And the time traveled, I'm going to write as 4.5 like this. So 4.5 hours. And then if we want to find what is the total distance traveled, we're going to multiply S, which is 62 miles per hour, times the time traveled is 4.5 hours. So what I'm noticing here is that if I multiply miles per hour by hours, anytime you have a matching factor in the numerator and denominator of a fraction, you could cross them off like this. So these units cancel out nicely, leaving us with just miles. So the distance in miles we could get by just multiplying 62 times 4.5. And if we punch that in a calculator, that's going to work out to 279 miles. And that matches up with choice D. So question 24, we're doing an algebraic substitution. We want to evaluate minus 4x minus 3y over 2x when x is negative 4 and y is 8. So here we have minus 4 times x. X is minus 4. And then we have minus, and then we have this fraction here. We have 3 times y over 2 times x. Well, just know here, maybe this will color code. We'll say x is this color here. So we have minus 4 for x. And 2 times x on bottom, we're going to replace x again with minus 4. And then the y term we'll replace in blue here with positive 8. So once again, notice I replaced 2 of these x's with negative 4, and the single y term gets replaced with positive 8. And now the rest is that we just have to simplify this. So this is going to work out to negative 4 times negative 4 is positive 16 minus, and here we have 3 times 8, and that's going to give us 24 over 2 times negative 4 is negative 8. And now if we simplify this is going to give us 16 minus 24 divided by negative 8 is negative 3. And if we do 16 minus negative 3, well, when you subtract the negative, the operation changes to addition here. We have 16 plus 3, which is equal to 19. And that's going to match up with choice E. So question 25 is another one of those unit questions. And what we have here is we're at a grocery store, and the shampoo sells for 14.5 cents per ounce. So I like to just write these things out, 14.5 cents. And the symbol for cents, we put the C with the strike through here. And per ounce, ounces we could say is OZ like this. That's just a nice abbreviation. So we want to know what is the cost of a 24-ounce bottle of shampoo. So what we do with this is anytime you have the rate, just know a rate, one of the giveaways here is the word per. So anytime you see per, this tells you that you have a rate. So in this case here, our rate, and I'll just transfer this over here. So our rate is equal to 14.5 cents per ounce. And what we have is we want to know the cost of a 24-ounce bottle of shampoo. So we take 24 ounces and we multiply it by the rate, which is 14.5 cents per ounce. And notice here we have ounces on top and ounces on bottom. So those units will cancel out. So when we do 24 times 14.5, the units are going to be in cents. So when you multiply these two numbers, you're going to get 348 cents. And now when we scan the answer choices, one last conversion to do. We're looking for the cost not in cents, we're looking for it in dollars. And just know every 100 cents is a dollar. So if we just scan the answer choices here, notice this is going to match up with choice C, because if we do 348 divided by 100, because there's 100 cents for every dollar, this is going to give us 3.48 like this. Now, if I really wanted to show as much work as possible, I could take 348 cents and I could convert the units here and say, well, for every $1, so for every $1, we have 100 cents. And then notice here that the cents are going to cancel out. We have cents on top and cents on bottom. And then ultimately we're doing 348 divided by 100. So that's why we're getting here that this is $3.48, with 3.48 being our actual number. Question 26, we're taking the verbal statement and writing it as an inequality. Now the phrase is no more than, we're going to translate as less than or equal to. We have 2 times a number. So this part here, 2 times a number, I'm just calling that 2x. Is no more than means that 2x is less than or equal to that number. So that number that they're referring to is x, because that's the mystery number. and then plus 12. So now we just piece all of this together. We have 2x is less than or equal to x plus 12. Now they're not actually telling us to solve it. We're just writing the inequality from the verbal description. So question 27, we have twice the number, so we'll call that 2 times x, divided by 4, so this is over 4, is, in math we say equals 16. So now we have to solve for what is the number x. And to do this, we could just write 16 as 16 over 1, and now we could cross multiply. We have 2x times 1 is 2x equals 16 times 4 is going to give us 64. So then to solve for x, the opposite of times 2 is divide by 2. And if we divide both sides by 2, that's going to give us x equals 32. So there's our solution to 27. So question 28, we're going to solve this inequality, then graph the solution. So for something like this, I like to treat it like an equation, and I'm going to start by just distributing. We have 2 times x is 2x, and we have 2 times negative 1 is negative 2, and that's greater than or equal to 6. Now, the only thing you have to be careful with inequalities is if you multiply or divide by negative, then the sign is going to flip. But here, if we're just doing something like plus 2 on both sides, that's not going to affect the greater than or equal to. So now we have 2x is greater than or equal to 8. And now dividing by positive 2 is not going to be a problem for the inequality. So this one we could kind of just treat it like it's an equation. So now we have x is greater than or equal to 4. Now this didn't print out too well, but 4 is over here. So I'm going to go ahead and write this a little bit clearer. So here's our 4, and our x values are greater than or equal to 4. So I'm going to put a circle here, and I'm going to color it in at 4, and I'm going to shade to the right. Because any x value in this set here, if I were to look at the next number, like let's say 5, 6, 7, 8, and so on, if I were to ask the question, is 5 greater than or equal to 4? That's true. 6 is greater than or equal to 4. So this is true for all numbers here that we're shading to the right of 4. Question 29, we're finding the perimeter of this triangle here. And the perimeter is going to be made up of these 3 sides. We're going to add the sides together. We have A plus B plus C, since these represent the 3 sides of the triangle. And now we just plug in. A is 14 inches, plus B is 10 inches, and C is 12 inches. So all we have to do here is just add the numbers. So we have 14 plus 10 is 24, and 24 plus 12 is 36. So we're going to have 36 inches. That is the perimeter of this triangle. So question 30, we want to find the area of the rectangle. And the area of a rectangle is equal to length times width. And we have the length and width here. So all we have to do is just plug in. We're going to have 12 centimeters times 7 centimeters. And just make sure that you're also writing the correct units here. We have 12 times 7 is 84. But when you do centimeters times centimeters, it puts centimeters here to the second power, but we would say 84 square centimeters is the area of this rectangle. Question 31, we have a 16-foot flag post. So that's this distance here is going to be 16. And what we're also told is that a support wire is attached from the top of the pole to a stake in the ground 12 feet away. So this piece here, that's the wire. So this is our wire, and it's attached to a stake in the ground that's 12 feet away. So here we go. And what we could assume here is that this is built well, and we're told that the pole is, or the post is perpendicular to the ground. That means we have a right angle here. And since we have a right angle, this is a right triangle, which means that for any right triangle, if you call the sides here A, B, and the hypotenuse across from the right angle C, that the Pythagorean theorem will apply. So we have a squared plus b squared equals c squared. So for a question like this, what we're going to say is the hypotenuse represents the length of the wire, and that's what we're looking for. What is the length of the wire in feet? So what I'll do is I'll just do it with the numbers and write the units at the end, but the answer is going to be in feet. So whatever the length of the wire is, we're going to write it in feet. So we would have 16 squared plus 12 squared is equal to, and if I put an x here for now, I'll just call this x squared. And now what we're going to have is 256 plus 12 times 12 is 144 equals x squared. And now we have 400 equals x squared. And then to get x by itself, the opposite of squaring is taking the square root. So we'll do that to both sides. And the square root of 400 is 20 because 20 times 20 is 400. So what is the length of the wire in feet? We could say the wire is 20 feet long. So question 32, we have this inequality, which we have a fraction on the left side is less than 9 on the right side. And what I like to do for these is get rid of the denominator, and we're multiplying both sides by 2. to do that, because when we multiply by this denominator, it's going to cancel out like this. 2 over 2 cancels. And now we have 3x plus 9 is less than 18. And as I mentioned before, you only have to be careful when you multiply or divide by negative. Since we multiplied by 2, we don't have to worry about the sign flipping. So now we're going to subtract 9 on both sides, and that's going to give us 3x, 9 minus 9 cancels, is less than 18 minus 9 is equal to 9. And now we just divide by 3, and we'll write the result over here. That's going to give us x is less than 3. So we find 3 on the number line. That's over here. And one thing to be careful of, it's x is strictly less than. So I'm going to put an open circle this time and shade everything to the left. Okay, a common mistake here is people might mistakenly color this in, but just know 3 is not part of the solution, because if you try to say x equals 3, well then 3 is less than 3 is a false statement. 3 is equal to itself. It can't be less than itself. But if you try a number like, let's say over here, like 2 or 1, if you plug that in, 2 is less than 3, 1 is less than 3. So this is true for all the numbers to the left of 3. So question 33, when we're comparing fractions, there's a few tricks you could use, but 7 over 12 is definitely greater than the fraction 4 over 9. So one way that I reason through this, there's like this cool little shortcut you could use when you have 7 over 12 versus 4 over 9. You could multiply in this direction here, say 12 times 4 is 48, and 9 times 7 is 63. And since 63 is a bigger number than 48, 7/12 wins the battle. So that's one way of reasoning that 7/12 is greater. Another way is I look at this and say 7/12 is definitely bigger than 1/2, because 6 over 12 is a half, so 7 over 12 would be more than a half. But if you notice 4/9, if I were to write 4.5 over 9, that's exactly equal to a half. However, notice 4.5 over 9 is greater than 4 over 9, which means that 4/9 is less than a half. So if 7/12 is greater than a half and 4/9 is less than a half, that means 7/12 is greater than 4/9. So that's the second way of doing this. You could use the halfway point of the fraction. The third way would be just to find common denominators. If I took 7 over 12 and multiply by 9 over 9, that would give us 63 over 108. And if we took 4 over 9 and multiply by 12 over 12, now we're going to have 108 on bottom and we're going to have 48 on top. So this is kind of like that shortcut over here. But notice when you have matching denominators, it's obvious that the first fraction here, 7/12, has a bigger numerator, so therefore it's the bigger fraction. So question 34, it helps to know that the distance covered is equal to the rate times time. And the rate is the one that has the word per attached to it. So this is our rate, and this is time, and this is distance traveled. So these questions here, we look for the rate and notice that our rate, R, is equal to 700 miles per hour, and we'll abbreviate that. And the time traveled is 4 hours. So the flight is going for 4 hours. Or that may not be the total flight, but they're asking after 4 hours in flight. So now we just plug in distance equals the rate is 700 miles per hour times, and we'll just make that a little bit neater. So we have 700 miles per hour times 4 hours like this. But the reason why I like to write the units in is notice hours over hours cancels, and it leaves us with just miles, which is the unit we want our answer in. So the distance traveled so far is 700 times 4, and that's going to be 2,800 miles. So our solution here is 2,800 miles. So question 35, we have a shop owner paid $12 for a shirt, and he marks it up to make an 80% profit. We want to know the price of the shirt, if it's more than, exactly, or less than $12.70. So there's two, once again, main ways to do this. What you could do is you could find 80% of 12, and then you could add that to 12 to see what is the price that the shop owner is charging. Now, when you want to find the percent of a number, just know 80% as a decimal, we would convert it to a fraction. That's 80 out of 100. And if we simplify this, if we could cross off common zeros, 8/10 is the same thing as 0.8. So what we could do with this information is we could take 12 and we could multiply by 0.8. And this would give us 9.6. So this is just calculator work here, or you could do 12 times 8 is 96, and then just move the decimal over one place. And now what you could do with that is you could take 12 plus 9.6, and if we set it up like this here, notice that we get the price that the shop owner charged is $21.60. So the shop owner is once again charging $21.60, and this is definitely more than $12.70. So question 35, there's another way we could do this. We could take the percent that we found before, 80% as a decimal was 0.8, and we could add it to 1. So we have 1 plus 0.8. And we take this value here and multiply it by the price of the shirt, or at least the price that the owner paid. And when we do 12 times 1 plus 0.8 is 1.8, notice that if you multiply these two together, it's going to give you 21.6 directly, which would tell you the price of the shirt that the owner is charging is $21.60. So what I wrote in green here, I prefer this, but I think the first way might be easier to understand. So for question 36, we're finding the unit rate. We have the price of gas is $19.48 for 5 gallons. And I'll just abbreviate that with a G. So if we want to find the price per gallon, what we're going to do here is just do 1948 divided by 5. And if we type this in a calculator, we're going to get $3. And this would round to 90 cents, but right now we have 896, and this is per gallon. So if we round to the nearest cent here, although I know some gas stations do that like extra 9 at the end, that fraction of a penny that I don't know how anyone would ever pay, but we have $3.90 if we round to the nearest cent. So the final question here, we have Flower estimated the percentages of her household using the pie chart. So there's two parts of this question. We want to know if her food budget is equal to, more than, or less than what she pays for rent and utilities. So the food budget, we're looking for this dark blue here. And the dark blue is corresponding to this value here, which is 30%. So the food budget is going to be 30%. And is this more than, less than, or equal to what she pays for rent and utilities? So rent is in light blue here. So that's 25%. So rent is 25%. And utilities is in green. That's 8%. So now if you think about this, 25% plus 8% would be a total of 33%. So notice the food budget is less than what she pays for rent and utilities. So less than is going to be our solution to A. So for part B, we're making a new category for Flower. So now she wants to pay off her student loans, and she's taking 2/3 of the percentage set aside as other. So other was an orange. That's over here. If we take 2/3 of 12%, notice here, when you're doing a fraction times a whole number, you could just divide the whole number by the denominator. So I could just do 12 divided by 3 is 4, and then 2 times 4 would give us 8% like this. So a second way of doing this, though, is you could do 2/3 times 12%. And just know when you do a fraction times a whole number, if you call the whole number over 1, this would be the same thing as 12 times 2, which is 24, divided by 3%. And 24 divided by 3 is still going to give you 8%. So that's now 8%. And we are comparing it to her budget for utilities. And utilities was in green. That was also 8%. So 2/3 of other is 8%. And that would be equal to the percent set aside to pay for utilities.